Happy morning, children. We are seeing sets, right? So in the previous class we have seen in sets introduction and what are the representation of sets. So today we are going to see what are the types of sets. Okay, so that is going to be our topic today. So let's quickly move on to our topic. So we'll start with what are sets. Just recall, set is a collection of well-defined and distinct elements. It should be well-defined and it should be distinct as well. There should not be any repetition. It should be each and every element should be distinct, right? And we have seen the representation of sets. What are they? One is roster form and the another one is set builder form, right? So these are the things we have seen, and this is going to be our today's learning objective. Today's yellow is to identify the sets, types of sets. Okay, so let's quickly move on. The types of sets, if you see, there are four main types of sets. The first one out of which is empty set or void set. So by the name itself you can identify all the four types actually. Empty set means what? There won't be any elements in the set, no elements. So we'll just usually denote it as 5. Okay, so A is equal to just empty braces, or else we can denote it as 5. There won't be any elements in the set. We'll call that kind of a set as empty set or void set. Your second type is finite set. By the name it will have definite number of elements. So it will have definite number of elements, that is, or a finite number of elements. Okay, the example, as you can see here, the example is collection of English alphabets, right? So it is A to Z, only 26 letters I will write it. Apart from that I don't have any elements to write in this. So the given example is a finite set, finite number of elements. The third one is just a converse of finite set, infinite set. If you have infinite number of elements in the set is called as infinite set. Here the example, you can see the example here. X is a natural number. So how many natural numbers you can write? It is 1, 2, 3, 4 going on, right? So you can say that this is an infinite set. So 1, 2, 3 going on, we cannot tell the last number at all. This is an example for infinite set. Your last type is equal set. Again, by the name itself we can say if two elements are having exactly the same element and the same number of element, then we can say that the two sets are equal. So if I have two sets having exactly the same element and the same number of element, then they are equal. For example, here A is equal to 1, 2, 3, 4, B is equal to 3, 1, 4, 2. No matter what is the order, but you have to see only the number of elements and what are the elements. Here we have 4 elements, 1, 2, 3, 4, and all the 4 elements is there in set B also. So we can say that set A and set B are equal. Got it? So these are the types of sets. So let's explore what are the types of sets. I'm going to give you a few examples to you and you will identify what type of set it is. Okay, so are you ready? Yes. So your first question here, which of the following are example of null set? So some statements will be given to you in set builder form. You have to tell whether it will be a null set or not. Your first question, set of odd natural number divisible by 2. It's an odd number divisible by 2. This is a set, okay? It is written in set builder form. How many elements will be there in this set? We have to see, and then we can say whether it is a null set or not. Now look at the statement, odd natural number divisible by 2. Will any odd number divisible by 2? Not at all, am I right? So there is no odd natural number which is divisible by 2. Therefore, we cannot write any elements in that set. It is a set only, but we cannot write any element in the set. So A equal to a null set. Okay, so it won't have any elements. So here the given example is the null set. Okay. Second question, set of even prime numbers. How many prime numbers are even? There is only one number which is 2. So in the given set I can write one element. What is that? It is 2. So A is equal to a 2 inside the braces, I can write 2. So it will have an element. 2 will be there in that set. So this example is not a null set. It will have one element. It is not a null set. Got it? Your next question. X is a natural number which satisfies X should be greater than 5. Sorry, X should be less than 5 and it should be greater than 7. It's just a number. It should satisfy both this condition. It should be less than 5 as well as it should be greater than 7. Is that possible? it should be less than 5 and it should be greater than 7 also. Is it possible? No, it is not at all possible. There is no natural number which is both x less than 5 and x greater than 7. We cannot find any number in that interval. So the given set is a null set. There is no elements for this example. So no elements, it is a null set. Your next question, why is a point common to any two parallel lines? How many points will be common to two parallel lines? We have to collect and write it inside the set. Will any parallel line have a common point? Definitely it will not have. Parallel lines will never meet. If they meet only, it will have the common point. Since they won't meet, there won't be any common point for parallel lines. Therefore, the given example is a null set. Got it, children? So, were you able to identify whether it is a null set or not? So, you should be able to find out how many elements will be there for the given set builder form. You need to identify the roster form. So, based on the roster form, you will tell whether it is a null set or not. Simple? Yes. So, your next question now. Which of the following sets are finite or infinite? Again, very, very simple. Which is finite, which is infinite? I'm going to give you all the set of questions to you first. Okay, we'll see the first question now. Set of lines which are parallel to x-axis. Just imagine your Cartesian plane. For x-axis, how many parallel lines I can draw? How many parallel lines? Infinitely many lines I can draw, right? So the given set is infinite set. You got it? Second question here, see this 1, 2, 3, etc. See that symbol clearly, 1, 2, 3, etc. going on. So this is again example of infinite set. Okay. Your third question, set of circles passing through the origin 0, 0. 0, 0 should be one of the points on the circle. How many circles I can draw like that? Too many circles I can draw? Yes. So with 0, 0 as one of the points for a circle, I can draw infinitely many circles. So the given example is infinite set. Your next question, set of positive integers greater than 100. After 100, how many large positive integers I can write? Again, infinitely many positive integers I can write. It will be going on like 101, 102, 103 going on. So it is infinite set. The set of animals living on the earth. Again, I can just count. It is possible to count what are the living organisms are there in the earth. So okay, it is fine. I can list out the set of animals living on the earth. So it is a finite set. Set of prime numbers less than 99. Less than 99, how many prime numbers are there? Can we identify easily? Can we list out? Definitely we can list out. So it is starting from 2, 3, 5, 7 like that. It will be going on till 99 we can stop. Okay. So we can say that the given example is a finite set. Got it, children? So were you able to identify finite and infinite? Very simple. We'll move on to the next question now. In the following, state whether A equal to B. There are two sets given to you. You have to say whether they are equal or not. Very, very simple. Again, you have to see whether the number of elements are same and the elements itself is same. Okay, now if you take the first question, here the elements are A, B, C, D. Here 4 elements are there in both. Okay, one is okay. You have to see the elements then. A, B, C, D is here. In the second one you see A, B, C, D. That is just given in the reverse order. No matter what is the order, we'll just see whether the number of elements and the elements are the same. So what about first question answer? They are equal. Superb. So second question, 4, 8, 12, 16, 8, 4, 16, 18. Though there are 4 elements in both the sets, if you see the elements, one is missing, right? One is here, we have 12, whereas the 12 is not here. Okay, here we have 18, but that 18 is not there in set A. So we can say that these two are not equal. Though they are equal in number of elements, it is not equal in elements. Okay, elements are different, so we will say that A is not equal to D. Come to the third question. 2, 4, 6, 8, 10 is your first set. Your second set is written in the set builder form. Just identify the roster form here. X is a positive even integer. It is a positive even integer which is less than or equal to 10. Okay, what are the positive even integers are there? Positive even integers which is less than or equal to 10. 2, 4, 6, 8, 10 again. So if you write the roster form for set B, again you will have 2, 4, 6, 8, 10 only. So the given two sets are equal sets. Super. Your next question, A is equal to X such that X is a multiple of 10. Here B is equal to 10, 15, 20, 25, 30. Look at this. What will be the elements in set A? Multiple of 10 means 10, 20, 30, 40 like that. Here it is 10, 15, 20, 25. It is multiple of 5. It is multiple of 10. So both are not equal. Got it, children? Yes, were you able to identify? Your next question, are the following pairs of sets equal? Give reason. You have to tell whether these pairs are equal or not as the previous sum. Your set A is 2, 3, set B is x is a solution of x square plus 5x plus 6. So first you have to identify the elements in B set. It's a solution of this quadratic equation. We know how to find the solution of a quadratic equation by factorization method, by splitting the middle term method, by formula method. Any method you can use. Find the roots. The roots only is the solution. So if you take x plus 2 into x plus 3 is equal to 0 will come. So x is equal to minus 2 comma minus 3. So if you take set A, it is 2 comma 3. If you take set B, your collection of the solutions minus 2 comma minus 3. Look at these two sets. They are not equal in elements, so it is not equal. Super. Question. From the sets given below, select equal sets. So there are 8 sets given to you. You have to select which are the sets are equal. Just don't see it as pink with blue. You can see it as 8 sets together, which are equal sets you need to identify. So can you identify? Yes, quickly. See, if you see B and D, they are having equal elements. Yes, all the elements are same. Similarly, if you see E and G, minus 1 comma 1 and 1 comma minus 1, both are same, right? So B is equal to D and E is equal to G. Simple? Super. So this is your task today. Just these two questions state whether each of the following sets are finite or infinite. I am giving you 4 examples for the set. You have to tell whether it is finite or infinite. And your second question is, are they equal? Set A and set B are equal or not? Okay. So I'll be waiting for your answers in the mainstream, children. Just go through this and come up with your answers. Okay. Thank you, children. Have a great day. So do all this in your classwork. Write all these questions in your classwork and practice on your own. Don't refer this. Just write the answers in your own. Very simple recap kind chapter it is. So write it on your own and practice well. Thank you, children.